Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. Today, inshallah, we'll continue what we have started last time, the review for year 5. Last time we took numerations, digits, place value, decimals, and rounding, approximating. Okay, today inshallah we'll continue with operations. Operations, it means adding, subtracting, multiplying, and dividing. First, we'll start with add whole numbers and decimals. What is the sequence of making an operation for two numbers or more? If we start with add 8,164 plus 4,676 equal. Start, I will make it mentally. I will have to do a rounding and estimating. If I round these numbers to the nearest thousand, okay, this is 8,164. For the thousand, I will have a look at the 1, the next digit to the right. It's 1, it's a poor number, so this number will be 8,000, okay, plus 4,676. I will have a look at 6 if I want to round this number to the nearest thousand. 6, it's a rich number, so this one will be added or increased by 1. It will be 5,000. The 4,676 will be rounded to 5,000. 8 plus 5, it means 13,000. So the estimation I made, it's about 13,000. The sum of these two numbers, it's about 13,000. Now, if I want to have it accurately or exact number, first I have to add the ones group. 4 plus 6 equal 0, equal 10. I will put the 0, okay, and have 1 up. Then I will add the tens group. 6 plus 7 equal 13. Increased by 1 that already I have it from before, okay, it will be 14. I will put the 4. So put the 4, okay, and carry 1 up, the tens of the 14, okay, then add the hundreds. 1 plus 6 equals 7. Adding the 1 before equal 8. Okay, then add the thousand group. 8 plus 4 equal 12. Now the result I have, it's 12,840. If I want to round this or approximate it to the nearest thousand, okay, I will have a look at the 8. It's a rich number, so this one will be, this digit of the thousands will be increased by 1, so it will be approximated to 13,000. So the number already I have approximated from before, it's already close to the exact result, final result I have for the adding. Okay, 12,840 if rounded, so it's close to 13,000. This is for whole numbers. What about decimals? Add 44 hundredths, 3 tenths, 85 hundredths. First by estimating and rounding, okay, I will have it approximated to the nearest tenth, okay. This is 4, this is the tenth. 4 is a poor number, so this one will be 0.4 plus, this is already 0.3 to the nearest tenth, it's 0.3 plus the tenth digit is 8. 5 is a rich number, so this one will be increased by 1, so it will be 9 tenths. Adding them, 4 plus 3 equals 7 plus 9 equals 16. So the result, the approximated and rounding, the result will be 1.6. Now have a look at the exact result will be I will have first line up the decimals, okay, point. I have to put the hundredth, then the tenth, okay, then the decimal point, and the 0 or the whole number I have. 4 plus 5 equal 9. 4 plus 3 equal 7. 7 plus 8 equal 15. The 5 will be put here, the decimal point will be down, and the 1 here. So the exact result, final result, it's 1.59 or 59 hundredths. If I wanted to round it to the nearest tenth, 9 is a rich number, so the 5 will be increased by 1, it will be 1.6. So the sum is very, very close to the estimation of this operation of adding decimals. Okay, that was for addition. So what about subtraction? It's the same, okay, but instead of increasing the number, it will be reduced. So subtract 4,816 minus 1,932. First, I have to make an estimation by rounding these two numbers, okay, to the nearest thousand. The 4 and the 1 is the digit of thousands. I will have a look at 8. It's a rich number, so this one will be 5,000 minus the 1 is the thousand digit. I will have a look at the 9. 9, it's a rich number because it's more than 5. Okay, so 1 will be increased by 1, so this will be 2,000. I will remove all these numbers and put zeros instead of them. 5,000 minus 2,000, it will be 3,000. So the estimated number for this subtraction or for this operation is 3,000. Now I have to subtract. First, I have to align my number, okay, my digits, ones, tens, hundreds, thousands, like we said before. 6 minus 2, it will be 4. 1 minus 3 can't be, okay, so I have to borrow 1 from this one. It will be 7, and this one will be 11. Why it's 11? Because the 100th digit, it's tenth of what? 10 times of the 10th digit. So I will increase 10. 10 plus 1, it means 11. 11 minus 3 equal 8. 7 minus 9 can't be, so I have to borrow 1 digit or 1 from the 1000 digit. This will be 3, and this one will be 17. 17 minus 8 equal 8. 17 minus 9 equal 8. Okay, then subtract the thousandth digit. 3 minus 1 equal 2. The exact final result is 2,884. If I want to round it to the nearest thousandths, the 2 in the thousandth digit, 8 is a rich number, so the 2 will be increased by 1. It will be rounded to 3,000. Okay, so the difference between these two numbers, or the final result of subtraction, is very close to the estimated number of 3,000. This is for subtracting whole numbers. If I want to subtract decimals, subtract 0.7 minus, okay, 0.7 or 7/10 minus 46 hundredths. Now, if I want to subtract them, I have to first round it to make an estimation for the nearest tenth. This is already for the nearest tenth. 0.7 minus, this is the tenth. 6, it's a rich number, so this number will be rounded as 0.5. 7 minus 5, it will be 2/10 or 0.2. Okay, then I have to subtract. I have to line my digits of the decimals. Now 0.7 or 7/10, it's the same amount of 70 hundredths. Because I have to subtract the same digits, the same number of digits. If it's here, it's tenth, will be tenth. If this one have hundredth, so the first number will have hundredth too. So 70 hundredth, it's the same amount of 7 tenth. So I have to increase the 0 here to make the subtraction. 0 minus 6 can't be, so I have to borrow this one. It will be 6, and this one will be 10. 10 minus 6 equal 4. 6 minus 4 equal 2. The decimal point will be down and the 0 as it is. 24. 24, if I have to round it to the nearest tenth, okay, the 4 is a poor number, so the 2 will be remain as the same, so it will be rounded to 0.2 or 2/10, okay, so then the difference is close to the estimate of 0.2. So we saw how to make the operations of addition and subtraction. The addition and subtraction operation have a relation between them. What is the relation? The relation that they are inverse operations. The addition and subtraction are inverse operations. How they are inverse operations? Inverse operations are mathematical operations that undo each other. Okay, it means that cancels what we have done in the other operation. Addition and subtraction are inverse operation. How? Now we'll see. Let A and B and C, okay, be any numbers. Any suppose. If A plus B equals C, then C minus B equal A. If A plus B equals C, then C minus B equal A. Subtraction undoes addition. If on the other side, the other hand, for subtraction, if C minus B equal A, then A plus B equals C. Addition undoes subtraction. Okay, now we knew that already the subtraction and addition are inverse operation. How we can use this property of these two operations? Now, if I have unknown numbers like x plus 5 equal 12 and I want to find the missing number, I have to think, what is the number that if it's added to 5 I will have 12? From the beginning, from primary, okay, 1 and 2, or maybe KG even, I know that already 7 plus 5 equal 12. So 7 plus 5 equal 12. So the missing number, it's what? It's 7. This is by thinking. But how I can do it with operations? I have to inverse the operation from addition to subtraction. I have to take the 5 from the 12 to know the number that already left. So that will be the missing number. So I have to say that 12 minus 5 equal 7. So 7 plus 5 equal 12, or 12 minus 5 equal 7, or even 12 minus 7 equal 5. These are related sentences. Okay, so if I have here an addition and I have a missing number, I have to do the inverse operation to get to get the missing number. Now, this is for addition. How I can undoes the subtraction? Find the missing number. X minus 9 equal 15. Now I have to think, what is the number that already I can subtract 9 from it? I will have 15 as a result. I have to think, it's 24. So 24 minus 9 equal 15. Now, if I add these two numbers to each others, I will have the missing number. 15 plus 9 equal 24. 24 minus 9 or 15 plus 9, they are related sentences. Even if I said 24 or 24 minus 15, it will be 9. All these sentences or mathematical sentences are related with each others by inverse operations. So addition and subtraction are inverse operation. Do I have other inverse operations? Yes, I have multiplication and division are inverse operation as inverse operations. Let A, B, and C be any numbers. If A multiply B or A times B equals C, then what is the number that already I can multiply it by B equal C? Okay, I have the missing number B. What is the number? I can multiply it by A, sorry. I will have C as a final result or a product for this operation. Now, if I divide C by B, I will have the A. Or I can divide the C by B equal the A. So A times B equals C. These are related what? Related operations. Now, A times B equals C. If I divide the C by B, I will have the A. And if I have C divided by B equal A, so if I multiply A by B, I will have the C as a result. So these are what multiplication undoes division and division undoes multiplication. Again, A times B equals C. If I divide the C by B, I will have the A. And if I divide C divided by B equal A, okay, so A times B equals C. Now we'll have an example to get it more. Find the missing number. Y divided by 6 equal 8. Y divided by 6 equal 8. Think about it. What is the number that y divided by 6 equal 18? Sorry. So I will think, what is the number that already I can divide it by 6? I will have 18. It will be 108. How to get it? Directly, I will have it if I make a reverse operation, an inverse operation, that I will multiply 18 times 6 to get the missing number. So 18 times 6. 8 times 6 equal 48. 8 and we'll have a 4 up. 1 times 6 equals 6 plus 8 plus 4, it will have 10. So the final result, it will be 108. 108 divided by 6 equal 18. 18 times 6 equal 108 are related sentences. Now we'll have to solve some examples. 8 plus A equal 12. Find the missing number. This is a subtraction, so I will have to do the inverse operation, which this is an addition. So I will have to do a subtraction as an inverse operation to get the missing number. I will have A equal 12 minus 8, so it will be 4. Now, if I have to think it about, 8 plus 4, already this is the number that I will have to add to get 12. Now, what is the number that if I subtract 40 from it, I will have 56. I will have to do an inverse operation, which is addition. So, n will be equal 56 plus 40. Okay, I will have 96 as a result. So the missing number or the unknown number, it will be 96 in this operation. Now I have 2h. It means 2 times h, or 2 multiplied by h, equal 101. Okay, this is a multiplication, so I have to do the inverse operation, which is division. So h will be 101 divided by 2. It will be equal, if I think it about mentally, 100 divided by 2, okay, it will be 50. And 1 divided by 2, it will be half. So this will be 50 and half, or 50.5, or 50 and 5/10. Now, y divided by 3, the last one, y divided by 3 equal to 133. I have to make an inverse operation. This is division, so I have to make a multiplication operation. This one, I have to multiply y equal 233 multiplied by 3 equal, and I have to align them. 3 times 3 equal 9, 3 times 3 equal 9, 2 times 3 equal 6. Okay, so the result will be, or the unknown number or the missing number will be 699. After we deal with addition, subtraction, and knew how to use the inverse operation to find the missing numbers, now we'll have some knowledge about the properties of addition and multiplication. If we have A, B, and C are like any numbers, okay, first property, we have the commutative property of addition, and also the multiplication have the same property. Now, the commutative, it means to change the order of the numbers. Okay, it means the first will be replaced instead of the second, or vice versa. So changing the order of the addends doesn't change the sum. It means if I say 5 plus 9 equal 14, or 9 plus 5, it will equal 14. It's the same, nothing changed. Also in the multiplication, changing the order of the factors doesn't change the product. If I said 3 times 8, it will be equal 8 times 3 equal 24, the same number. So commutative property, it's already included in the addition or the multiplication operations. Now, associative property, also it's presented in the addition or multiplication. What is the meaning of associative property? It means changing the grouping of the addends doesn't change the sum. It means if I have 3 numbers, if I get the sum of the first 2 numbers, then add it to the third one, it's the same if I add the second and third first, then I add them to the first. Like here, if I have 1 plus 4 first as 5 plus 7, it will equal 12. Or if I have 4 plus 7 first as 11, then I add 1 to them, it will be also 12. The same in multiplication. If I change the grouping of the factors, the product will not be changed. If I say 6 times 5 first as a 30, then multiply it by 2, it will be 60. Or if I multiply 5 by 2 as a 10, then times it by 6, it will be 60. Nothing will be changed. The third property here is the identity property. For addition, the sum of 0 and a number, okay, it will equal the same number. if I sum 0 to any number, the result will be, the sum will be the same number. It means if I say 89 plus 0, it will equal 0 plus 89, the commutative property. It will have 89 as the same number. Nothing changed. I will put nothing. I will add nothing to anything. It will be the same thing. Now, for multiplication, the product of 1 and the number is that same number. If I multiply any number by 1, okay, if I leave anyone by himself, it will remain the same. If I multiply 1 by any number, the product will be the same number. So the identity property for addition is the 0, related with 0, and the identity property for the multiplication related with 1. Okay, then we'll have the 0 property of multiplication. Now if I add 0 for any number, it will remain the same number, but if I multiply 0 for any number, I will have 0, not the same number. I will have 0. If I multiply 0 by any number, it will have 0. Now I have to rename or name some properties of the addition or multiplication I use in these operations. Now first I have 18 plus 53 equal 53 plus 18. What did I do here? I only changed the order of the addends. So this is the commutative property. Okay, to name it, just to mention which property we have it here, or we use it here. Now 2 times between brackets 30 times 80 equal 2 times 30 between brackets, then times pi or multiplied by 8. Changing the grouping, it means which property is associative property. Now 90 plus 0 equal 90, so I added 0 to a number, it will be the same number. So this is the identity what? Identity for addition. The other one, 1 times 25 equal 25. I multiply 25 by 1, it will have the same number as a product. This is the identity for, okay, property for what? For multiplication. So this is all about the properties of addition and multiplication. And before we have how to use the operations already to get the result as a sum or subtract or multiply or divide, and have the inverse operation, how to get the missing number. This is all about it. Okay, now after this we'll have to multiply 1 and 2 digit numbers and know how to do it. So multiply 1 and 2 digit numbers. First, if I multiply a number by a 1 digit number, like 7 times 27 equal, I have to have the product first by estimation. Okay, so I have to round this will remain 7 times, round this one to the nearest tens. Okay, this is the 10th digit, 7 is a rich number, so this one will be 30. So 7 times 3 equal 21, and have the 0 as it is will come here. So the result by estimation is 210. Now I will have to do the multiplication to get the exact product. Now I have to first to multiply the ones, then regroup. then multiply the tens, then regroup. Okay, this is the ones, this is the tens. 7 times 7, I will have 49. I will put the 9 and get the 4 up. 2 times 7, it's 14. 14 plus 4, I will have like 18. So the exact product, it will have 189. 189, okay, it's close of what? Of 210. Of 210. Okay, so this is close to the estimation. Now, if I want to multiply a number by 2-digit numbers, first I have to estimate by rounding. If I make it rounded to nearest tens, okay, this is the 3 as a 10th digit and 4 here as a 10th digit. 2 is a poor number, so this one will remain 30 as it is, times 6 is a rich number, so this one will be increased by 1, it will be 5, so it's 50. 30 times 50. 3 times 5, it will be 15, and I will have 2 zeros to be here in the result. It will be 1,500. This is the estimation of mine. Then, to have the exact result, first I have to multiply the ones. This is the ones, this is the tens, okay? Once to multiply 46 by 2, then to multiply 46 by 3. Had the partial products. 6 times 2, it's 12. I will put 2 and carry 1 up. Okay. 4 times 2 equal 8 plus 1, it will be equal 9. This is, I have the product for the ones. Then I will have to make partial products for the, this is the ones, and I will have it for tens. So I will leave the ones digit empty as 0. Now 6 times 3 equal 18. 8 and carry 1 up. 4 times 3 equal 12. 12 plus 1 equal 13. Okay, this is the partial product for ones and this is the partial product for tens. Now I have to add to get the final product. 2 plus 0 equal 2. 9 plus 8 equals 17. 7 and carry 1 up. Okay, 0 plus 3 equals 3 plus 1 equal what? Equal 4. Then 0 plus 1, why I said here 0? Because it's an empty digit and 1 will have it down. Now the exact result will be 1472. If I have to round it to the nearest hundredth, this is the 100th digit. 7 is a rich number, so it will be 1500. So the product is close to what I have estimated before in the beginning. This is for multiplication. Now for division, I have to make a trial quotients. Okay, if I say 2183 divided by 46, I have to follow these steps. First, decide where to begin the quotients. Okay, now I have to look at here. The 2183, okay, 2 is smaller than 46, so it can't be divided by 46. Then I will have the 21, the tens. 21 is less than 46, so can be divided by 46. Then I will increase one digit, 218. 218, it's greater than 46, or 46 is less than 218. Okay, so this can be divided by 46. So the quotients begins in the tens place. Now I have to estimate. First, I will have the 21 divided by 4. I have 2-digit numbers, 2 divided by the tens digit. Okay, 21 divided by 4, it will have 5. Okay, now I have to multiply the 5 by 46. 5 times 6, it's 30. 0 and have the 3. 5 times 4 equal 20. 20 plus 3, it will be 23. Oh, this is 230. I have to subtract. Already 218 is smaller than 230. Okay, so the digit used in the quotients is too large. 5, it's not a suitable number. So I will try a less number. I will try the 4. 46, 2183. Okay, I will try the 4. 4 times 6. Okay, I will have the multiply. 4 times 6 equal 24. I will have the 4, get the 2 up. 4 times 4 equals 16. 16 plus 2 equal 18. So this is 184. It's less than 218. So 4 is a suitable result. Now I will have to subtract. 8 minus 4 equal 4. 1 minus 8 can't be. This one will be 1 and this is 11. 11 minus 8, it will be 3. 1 minus 1 equal 0. Okay, I can maybe next time I won't try the 0. 0 on the left side, it's useless. But I type it here only for explanation. Now, 34 is less than 46, can be divided by 46. It will be a fraction. So I will have the 3 down. Put it here. So I will have 343. It's already greater than 46. Okay. I will repeat the steps. I will get the 34. Okay. Divided by 4. 34 divided by 4, I have 8. So I can put the 8. Okay. 8 times 6, I will have 48. 8 and have the 4. Okay. Then 8 times 4 equal 32. 32 plus 4, it will be 36. 36, it means 386. It's already greater than 334. So I will have to replace the 8 with a 7. 7 times 6, okay, it's 42. 2 and have the 4. 7 times 4 equal 28. 28 plus 4, I will have 32. Now it's already closed. 3 minus 2 equal 1. 4 minus 2 equal 2. 3 minus 3 equals 0. So I have a quotient as 47 and remainder as 21. Okay, so I have now to check. Check what? Check 46 times 47. It will equal how much? 46 times 47, like we did before. First, I will have the product of the ones. Okay, 6 times 7 equal 42. 2 and have 4 up. Okay, 4 times 7 equal 28. 28 plus 4, okay, it's 32. This is the partial product, the first partial product. Then I will have the product of the tens. 6 times 4 equal 24. Here I will put the 0. In the ones digit I will put the 0. 6 times 4 equal 24. Here is the 4 and have 2 up. Okay, 4 times 4 equal 16. 16 plus 2 equal 18. Then I have to add. This is the second partial product. 2 plus 0 equal 2. 2 plus 4 equal 6. 3 plus 8 equal 11. 11 and have 1 up. 1 plus 1 equal 2. Okay, so this is 2162. Okay, plus the remainder that already I have, it's 21. 2 plus 1 equal 3. 6 plus 2 equal 8. 1 plus 0 equal 1. Okay, 2 plus 0 equal 2. 2183. This is already the number that I have to divide it by 46. So the checking of the operation brings me that already my quotient is correct. That already the quotient is 47 and the remainder is 21. The quotient is 47 and the remainder is 21. This is how we divide by trial. Now, how we can divide whole numbers without trials. Dividing whole numbers, for example, divide 4,782 divided by 83. First, as we said before, we have to decide where to begin the quotient. Now, I have the 4,782. I will have the tens, okay, digits. 47 divided by 83 can be, because 47 is less than 83 or 83 is greater than 47. So I will take the next digit. It will be 478. Of course, I can divide it by 83 because it's greater than 83 or 83 is less than the 400. So the quotient will begins in the tens place. I will have the 478 divided by 83. I will take, okay, the 47 divided by 8. If I divide 47 divided by 8, I will have 5. It's 40. So I will put the 5. Then I will times or multiply the 5 by 83. 5 times 3 equal 15. Okay, put the 5 and have 1. 5 times 8 have 1. 5 times 8 equal 40 plus 1, it's 41. Yes, the trial is correct because 415 is less than 478. So I have to subtract. 8 minus 5 equal 3. 7 minus 1 equal 6. Okay, 4 minus 4 equals 0. I want to put it. It's on the left side. It's useless. So 63 divided by 83 can be, because 63 is less than 83 or 83 is greater than 63. So I will bring the 2 down. Now I have 632 divided by 83. 62 divided by 8. Okay. Sorry, 63 divided by 8. So I will have a 7. Okay. 7 times 83. 7 times 3 equal 21. Put the 1. Okay, and have 2 up. 7 times 8 equal 56. 56 plus 2, it will be 58. Okay, then I will subtract. 2 minus 1 equal 1. 3 times 8 can be, so I will pour 1. 5, and this is 13. 13 minus 8 equal 50. Okay, so 51 is less than 83, so the quotient will be 57 and the remainder will be 51. Okay, the quotient will be 57 with remainder 51. Now I have to check, so I will make 57 times 83 7 times 3 equal 21, 1 and a half 2 up. 5 times 3 equal 15 and 2 equal 17. This is the first partial product. Then I will put the 0 at the ones digit. 7 times 8 equal 56, 6 and then I have 5. Okay, 5 times 8 equal 40 plus 5 equal 45. Then I will add 1 plus 0 equal 1, 7 plus 6 equal 13, 3 and carry 1 up. 1 plus 1 equal 2 plus 5 equals 7 and the 4 will be done. This is the quotient, this is the product of 57 times 83 with a remainder plus 51. It will be 2, 8, 7, 4. It's the same number as the number we divided by 83. So the result or the quotient and the remainder is correct. Now, this is for whole numbers. How to divide, okay, decimals. First, I have to think and estimate already. 0.9 divided by 3. Okay, if I approximate or round this number to the nearest tenth, it will be 9/10. If I divide it by 3, okay, it will be 30. Okay, it will be 30 hundredths. So the result will be close to 0.3. Now, I will put 0 divided by 3. It will be 0 and have the decimal point as it is. Okay, then 8, okay, divided by 3, it's equal to 2 times 3 equal 6. Okay, with negative. To subtract 4 minus 0, of course, it will be 4. 8 minus 6, it will be 2. And decimal and the 0 as it is. 24 divided by 3. Okay, 24 divided by 3 equal 8. So the quotient here equal 28 hundredths. If it's approximated to the nearest tenth, 8 is the rich number, so the 2 will be increased by 1, so it will be 0.3 if I round it to the nearest tenth. Okay, so another example. 3.991 hundredths divided by 23. Okay, now if I approximate the 391, it will be to the nearest hundredth, it will be 400, or to the nearest whole unit or whole number, it will be 4. Okay, and the 23 will be approximated to 20. So estimate 4 divided by 20. It means like 400 divided by 20 will have 2, but it will have 0.20. Okay, it will be 20/10. It will be 20/10. Okay, so now we'll have the exact or the accurate quotient. 3 divided by 23, okay, can't be. So I will take the 9. But first I have to put the 0. 3 divided by 23 equals 0. Okay, because I put the 0 because it can be divided by 23. It's less than 23. So I will have the 39 or 3.9 because I will put the decimal point here. 3.9 or 39 divided by 23. Okay, I will have 1 because 2 times 23 it's 46. So I will have 1. 1 times 23 it will be 23. Okay, subtract. I will have 9 minus 3 equal 6. 3 minus 2 equal 1. 16 divided by 23 can be because it's less than 23, so I will have the 1 down. 161 divided by 23, okay, I will have 16 divided by 2, it will be 8, but 8 it will be more than this result. So I will take the 7. 7 times 23, 7 times 23, it will be 21, 1 and have 2 up. 7 times 2 equal 14 plus 2 equal 16, so 0 with no remainder. The quotient here is 0.17 or 1700. If I round it to the nearest tenth, it will be 20 hundredths or 0.2. So the quotient is close to the estimated quotient is close to the accurate quotient. Okay, so that was for whole numbers and decimals. Okay, now we'll have a look at fractions, how to add and subtract fraction with like denominators. To add fractions with like denominators, first add the numerators. Okay, we'll have the above term, the upper term to be added, then write the result over the common denominator. Third, express the function in the simplest form. Like what? If I have 2 over 8 plus 4 over 8, now I will add the numerators. 2 plus 4 equals 6 over the common denominator, which is 8, so it will be 6 over 8. The GCF of 6 and 8, okay, is 2. The greatest common factor between 6 and 8 is 2. So I have to divide them, the numerator and the denominator, by 2 to have the simplest form. 6 divided by 2 equals 3, 8 divided by 2 equals 4. 3 is a prime number and 4 can be divided by 3. So this is the simplest form of my sum. Now if I have to represent it on the number line, I will put the 0 and put the 1, then divide these into 8 units. 1, 2, 3, 4, 5, 6, 7, 8. Each unit of it is numbered by 1, 2, 3, 4, 5, 6, 7, and the 8th one, it's 8 over 8, which is what? Which is 1. And the 0, which is 0 over 8, which equals 0. Then, I have it here 2. So, from 0, I will jump 2 units to reach the first addends, okay? Then, take the 4 steps, 1, 2, 3, 4, I will reach to 6 over 8. This is the result of my sum. This is for addition. What about subtraction? Now, if I subtract 4 over 8 minus 2 over 8, first I have to subtract the numerators. 4 minus 2 equals 2. Then I will put it over the common denominator, which is 8. So the result, it's 2 over 8. 2 and 8 are prime numbers, and 2, the greatest common factor of 2 and 8 is 8, because 2 is a factor of 8. So 2 divided by 2 equals 1, 8 divided by 2 equals 4, 1 over 4, it's the simplest form. How to represent it on the number line? I will have the number line as we said before. Divide the unit from 0 to 1 into equally 8 units, okay? Then I will jump to the 4 over 8, okay? This is the start point. Then I will have back 2 steps to reach 2 over 8. To reach 2 over 8. This is the result of mine, and the simplest form of it is 1 over 4. So, at the end, we knew all operations about whole numbers, decimals, and fractions. The operations as addition, subtraction, multiplication, and division. We knew the inverse operation and how to make divide a multiplication for 1 and 2 digit numbers, how to divide whole numbers and decimals, then how to add and subtract fraction with like denominators. I hope that you got it all, okay? And next time, inshallah, we have statistics and graphs in the next review before we start the basic or the main syllabus of year 6. Hope to enjoy it. Remember me in your prayers, and please follow or like my page and subscribe in my channel on YouTube to go the most benefit for all of you. Thank you so much, and see you inshallah. Bye.